Welcome to Maths with EJD. In this video, I'll be talking about basic trigonometric identities. Basic trigonometric identities. Now, one thing you need to understand when you're dealing with trigonometry generally is that anytime you have a trick question to solve, you have to think, you have to be, it's more like you have to put up your antenna to scan all the possibilities you need in a particular situation. Because sometimes if you don't remember a particular idea, you may be stuck on a trigonometric question. So you need to be able to, your head needs to be spinning around, like thinking about, you may, in a situation, all you may need to remember is the fact that sine over cos is tan, or that cos over sine is cot, and things like that. So, or that 1 over sine is sec, or and things like that. So whenever you have a trick question, you have to be scanning around for all those information for you to be able to solve problems. So in this video, of course, we'll be talking about some basic trigonometric identities that will help you dissolve any trigonometric problem that comes your way. Okay, so of course, we have the foundation set already. Like in previous videos, we have already seen how that sine over cos is tan and things like that. If you have sine theta, okay, let me even draw a proper right angle triangle as much as I can. So let's say this is angle theta, and of course, with that being theta, right? Let's now say this is this is A, and this is B. Now this is C, right? If we say that. So um you know already that si sine theta, sine theta is A over B. You know that cos theta is equal to B. Okay, no. Sine theta is opposite, right? Sine theta, in fact, let me change the color. You know that sine theta, let me use something a bit dark. So sine theta is opposite A over hypotenuse C. Then you know that cos theta is adjacent B over hypotenuse C. You know that cos theta tan theta now, tan theta, tan theta is equal to, tan theta is opposite A over adjacent B. And of course, they are reciprocals. You have you, you have what you know as cosec theta, that is 1 over sine theta, and that is C over A. And then, of course, you have sec theta, which is the reciprocal of cos theta, which is C over B. And lastly, you have cot theta, which is 1 over tan theta, and that is B over A, like that. So, and of course, generally speaking, we also came across the fact that sine theta over cos theta is equal to tan theta. Of course, that is easy to see because sine theta over cos theta, that's A over C divided by B over C, and that is equal to A over C times C over B. This cancels out and you have A over B, which is simply the same thing as tan theta, right? Tan theta here. So that's that very clear idea, very nice thing to know. And of course, we can also extend that to the idea of cot, right? Knowing that cos theta over sine theta is the same thing as cot theta. So it's just a matter of checking things out. Cos theta is B over C, and sine theta is A over C, divided by A over C. So you have B over C times C over A. Cancel this out. So you have B over A, which is cot theta. So that's well established. Now, we just want to want to advance this idea. What if you combine these things with the idea of Pythagoras theorem? From Pythagoras theorem, what do we have? Remember, from Pythagoras theorem, from Pythagoras theorem, we simply have that a squared plus b squared is equal to c squared. That is what Pythagoras theorem tells us. Now, can you try to combine the Pythagoras theorem with the trig ratios? These are the trig ratios, the trigonometric ratios. We did that previously. So try to combine this and see what happens. For instance, let's call this equation 1, for instance, and divide through by c squared. If you divide through by c squared, that means you have a squared over c squared plus b squared over c squared equals c squared over c squared. That means you have a over c all squared plus b over c all squared equals 1 in short. That's simply 1. Now, what is a over c? You remember a over c is sine theta, right? So that means a over c squared is sine theta all squared. And what is b over c? You remember b over c is cos theta, right? So you have cos theta raised to power 2, and that is 1. So from that, what do we see? We simply see that sine squared theta plus cos squared theta is equal to 1. So this is going to be a very powerful tool for us in our trigonometric journey. So from this, right, from this, you can extend this now to know that sine squared theta sine squared theta is equal to 1 minus cos squared theta. Then you also know that you can extend that to do this. That's cos squared theta is equal to 1 minus sine squared theta. This is 1 minus cos squared theta. So, I mean, that's one thing. So it's really important to have this established. Very important. So now in solving some problems, in fact, if you go back to some things I've done in calculus, like trying to integrate something like cos squared x or sine squared x, if you try to integrate cos squared x, if you're trying to integrate sine squared x, you will need this idea, because to integrate it directly is not easy. So you have to use some trig identities that we are going to talk about later. So this idea is very useful in other aspects. So it's really important to pay attention to this, even in complex numbers. When I talked about complex numbers, so you can go to the playlist on complex numbers when I was talking about De Moivre's theorem. So you see that these ideas are pretty useful there. Okay, so that's one identity, right? So now, can we check something else? What if we have, again, we go back to the Pythagoras theorem, right? Okay, we can call this equation, I mean, you can name all these equations. Let's say this is equation 3. I mean, or is it equation 2? We should call that now. So let's say this is equation 2, this is equation 3, and this is equation 4, if you like. You can say this is equation 4, okay? Now, so that's settled. So back to, what if you divide equation 1 through by, say, so can you divide equation 1 through by, say, b? Let's divide equation 1 through by b, for instance. So, we have divided by c. So we divided by c squared. Let's divide by b squared. So again, let's say divide. Okay, let me go black this time. Divide, divide, divide equation 1 through by b squared. What do we get? We have a squared all over b squared plus b squared all over b squared equals c squared all over b squared, So that is a over b all squared plus 1 equals c over b all squared. Now, what do we see? A over b again. A over b is tan, A over b is tan. So we have tan theta, or like I write, tan A over b is tan theta all squared plus 1 equals c over b. If you check up there, c over b is sec theta, So this is sec theta all squared. So what do we see here? Tan squared theta plus 1 equals sec squared theta. So you see, this idea is also useful when you do maybe when you differentiate things like the inverse of the inverse of tan theta. So this information can be pretty useful. So you see, this is another identity here. So you can call this, if you like, call this equation 5, call this equation 5. And from here, we can get other identities like, you need to understand here that sec squared theta minus 1 is equal to tan squared theta, that's a useful thing. And then if you like, you can call this equation 6. And then still from here, you can say that sec squared theta minus tan squared theta is equal to 1. This is another very important one. Call that equation 7, if you will. Right? So these are very useful identities you can play with in your trig journey. Okay, so we divided by c squared, we divided by b squared. Now, can we divide the same equation 1? So that Pythagorean identity, right? A squared plus b squared equals c squared. So can we divide equation 1 again by a squared? So that means that this is same equation 1, a squared plus b squared equals c squared divided by a squared now. So you have a squared divided by a squared plus b squared divided by a squared equals c squared divided by a squared, right? So that means you have 1 plus b over a all squared equals c over a all squared. Now we have 1 plus, what is b over a? From all the basic trig identities, b over a is actually cot. So that's cot theta, that is cot theta. So you have cot theta all squared equals, what is c over a? C over a. C over a is cosec theta. That's cosec theta. That's c over a. Okay, this is how we write cosec now. CSC theta all squared. So now you see that 1 plus cot squared theta is equal to cosec squared theta. So now we have another identity, which you can call equation 8, if you will. So this is equation 8. And based on this, now we can get other things like the fact that you know uh cosec squared theta minus 1 is equal to cot squared theta. Important. Call that equation 9. And then from here still, you can say that cosec squared theta minus cot squared theta is equal to 1. And then you can call that equation 10. So all these ideas are very useful in solving trig problems. So I'm going to write down 3 problems and then I'll solve. Okay, I'm going to write down, okay, I think I have 5 of them. I'm going to write down those 5 problems and then I'll solve. Okay, you know what I'm going to do? I have 5 problems to solve. Then I'll do 1, 3, and 5, and then you take the other 2 as assignment. I mean, as something you want to practice with. Okay, so let's take the first one, and it is going to test our knowledge of what we have just done now. So the first one is we want to show, we want to show, we want to show that, we want to show that sine squared theta plus 1 plus cos squared theta is equal to 2 into 1 plus cos theta. So now this is the question. The question is more like, show that sine squared theta plus 1 plus cos squared theta squared, like this. So sine squared theta plus 1 plus cos squared theta squared is the same thing as 2 into 1 plus cos theta. So that's all we are required to show. Okay, I think this is a mistake. Yeah. So sine squared theta plus 1 plus cos theta all squared is equal to 2 into 1 plus cos theta. So we need to solve this. Okay. So now see what you have. You have sine squared theta plus 1 plus cos theta all squared. So you want to start from here and end up here, basically. So, I mean, we can already, we can expand this, right? This is like a plus b squared, and we know that is a squared plus 2 times ab plus b squared. That's an aside, and that's the idea we want to use here. So you have your normal sine squared theta plus, so if you do this idea here, so that means you have 1 squared plus 2 times 1 times cos theta based on this 2ab, plus cos theta all squared. So that means you have sine squared theta plus 1 plus 2 cos theta plus cos squared theta. Okay, easy peasy. Sine squared theta plus cos squared theta is 1. You can say that. So you have, okay, I mean, let's go the journey. So sine squared theta plus cos squared theta plus 1 plus 2 cos theta. So you know this is 1 already. So this is 1 plus the one that was there before plus 2 cos theta. And 1 plus 1 is 2. So you have 2 plus 2 cos theta. Okay. And then this is 2 into 1 plus cos theta. So, I mean, we even got there faster than we expected. So that is what we expected to show, that this expression is the same thing as 2 into 1 plus cos theta. So you have your answer right there, okay? So I'll skip the second question and leave it as exercise for you, which I'm going to write out later. So the next question, right, that I like to solve is question 3 out of the 5 I'm supposed to talk about. Okay, so let's see how that works. Okay, now look at this. Look at what we have here. We want to show now, to show, this is a bit tricky, to show that x squared plus y squared plus z squared is equal to c squared if x is c sine theta cos phi, y is equal to c sine theta sine phi, right? And z is c cos theta. So we want to show that x squared plus y squared plus z squared is equal to c squared. That's what we have to show in this case. All right. So what do we do? Okay, so we have this now. So let's go for this. Now we need to show that x squared plus y squared plus z squared is the same thing as c squared. So that means that we can start with x squared plus y squared plus z squared and end up at c squared. So let's go x squared plus y squared plus z squared is equal to, what is x? X is c sine theta cos phi all squared. And what is y? C sine theta sine phi all squared plus c cos theta all squared. Okay, so we can expand all this. So if you expand this now, you have c squared sine squared theta cos squared phi, right? Right, plus c squared sine squared theta sine squared theta cos squared phi, cos squared phi. Sorry, this should be phi. Then the z is c cos theta, right? So you have c squared cos squared theta, cos squared theta, yes, cos squared theta. So okay, let me tidy this up so to avoid confusion. This is c cos theta, right? And then this is phi, to avoid confusion. This is phi based on what we have up there. Okay, so now that we've expanded this, right, we need to tidy things up. So from here, what can we see already? We can take out, we can see, look at sine squared theta, cos squared phi. What is common here? We see sine squared theta is common in this place. So let's try to tidy that up. So we have c squared, sine squared theta into cos squared phi plus cos squared into cos squared phi. Okay. So I think I have an issue with this one. C sine theta, C sine theta, C sine theta, sine squared theta cos sine. Sorry, there's a lot of stumbling. C squared sine squared theta sine squared phi. Yes, that's some confusion there. So it means C squared sine squared theta is common to this. So you have cos squared phi plus sine squared phi. You see, so you see c sine squared theta is common. C sine squared theta is common. And then what do you have left? Cos squared phi, and then you have sine squared phi left, plus c squared cos squared theta. Okay. So now this is automatically 1, as we know. So it means we just have c squared sine squared theta multiplied by 1 plus c squared cos squared theta. And then we have c squared sine squared theta. Don't mind me, I just like to go baby steps. C squared cos squared theta now. So the next thing we have is c squared is common into sine squared theta plus cos squared theta. So sine squared theta plus cos squared theta is 1 again. So we have c squared into 1, of course, and that is simply c squared. So we can now say, therefore, x squared plus y squared plus z squared is equal to c squared, as expected. Okay, so that's the second question I'm taking. So I have one more to go. Then I'll drop 2 for everybody to play with. I'll drop 2 for everybody to play with. You can try your hands on those to check them out. So the next one I'm going to do is this. We need to show, right? We need to show that 1 plus cos theta, 1 plus cos theta over 1 minus cos theta, all right, times sec theta minus 1 all over sec theta plus 1 is equal to 1. That's another thing we need to show. So you can see that everything we have been doing so far, you see the trigonometric identities have been helpful in resolving them. Sin squared theta plus cos squared theta and all those things are really helpful. So here we want to show that 1 plus cos theta over 1 minus cos theta times sec theta minus 1 all over sec theta plus 1 is equal to 1. Okay? And, that's what we need to show. So it means that you start from here and end up with 1, basically. So you have 1 plus cos theta all over 1 minus cos theta times sec theta minus 1 all over sec theta plus 1. So, and that means you have, now, for me, like, it's always very good to work with the basic trig ratios like sine, cos, and tan. So anywhere you see anything that doesn't look like them, bring them back into that arena. So it means you can say 1 plus cos theta all over 1 minus cos theta times sec theta is, sec is the reciprocal of cos. So you have 1 over cos theta, that's sec theta minus 1 all over 1 up there, all over 1 over cos theta plus 1 all over 1 down there, right? And that is equal to 1 plus cos theta all over 1 minus cos theta times, for the top, you can take the LCM, which is cos theta, right? So cos theta in cos theta is 1. 1 times 1 is 1. Minus 1 in cos theta is cos theta times 1. That's cos theta. All over, again, you take the LCM for this. So that is cos theta again. Cos theta in cos theta is 1 plus 1 in cos theta is 1 plus cos theta again. And, you can try to tidy things up. You have 1 plus cos theta all over 1 minus cos theta times, so, this is, you can break this apart. You have 1 minus cos theta all over cos theta here, divided by, divided So you can say divided by, or I mean to make things fast, right? You know, if you divide by this, so if you want to multiply by it, it means the cos goes up. So the cos theta will go up. So you have cos theta all over 1 plus cos theta. So by doing this, I've saved myself some stress. So it is this divided by this, right? So this divided by this means that to multiply by it, cos will go up and 1 plus cos theta will come down. So with this now, you have 1 cos theta, 1 plus cos theta cancel out. 1 minus cos theta, 1 minus cos theta will cancel out. So, and you have cos theta, cos theta. So at the end of the day, everything is just 1, right? So that is what we need to prove. So you can say, therefore, that expression is equal to 1. So that is quite easily done, as some people would like to say. So you can get your practice questions now. So practice questions, practice questions, practice questions. Try your hands on this and see how well you can do with them. Okay. So, yes. The first one is show, show that, show that 1 plus sine theta, 1 plus sine theta, all over 1 plus cos theta times 1 plus sec theta all over 1 plus cosec theta is the same thing as tan theta. So 1 plus sine theta over 1 over cos theta times 1 plus sec theta over 1 plus cosec theta is equal to tan theta. That you have to show that. Then the second question is this, a bit tricky, but of course, I'm sure not beyond you. Question 2, you need to show that x prime, let me take it down. So x prime squared plus y prime squared is equal to x squared plus y squared, right? If x prime is equal to x cos theta plus y sine theta, and y prime is equal to x sine theta minus y cos theta. That's what you need to show. So show this, all right? Show this given this, all right? So I go over that again. Show that x prime squared plus y prime squared is equal to x squared plus y squared if x prime is x cos theta plus y sine theta and y prime is x sine theta minus y cos theta. So that's your practice question. So try your hands on them and see what you can do with that. So with that, I come to the end of this video. Be sure to subscribe if you have not done that already. Hit the notification bell so you can get alerted each time I release a new video. And of course, you want to like, share, and comment. If you have a problem for me to solve, feel free to let me know by commenting. And of course, we can always have a nice time learning maths together. See you in the next video.